All right, welcome back. ELM Prep, Part 8, and we're continuing in Part 2 of our absolute discussion. We ended with this problem of the absolute value of x plus 2 greater than 3. And we said the potential here was the minus this quantity, x plus 2, is greater than 3. The difficulty comes when this was equal to, all we did was move the negative to the other side. Here's where we have to be extremely cautious of inequalities and dividing or multiplying by a negative. If I divide both sides by the negative 1 to get rid of that negative, I have to be careful and look at this thing here. The inequality sign will change direction. This is greater than, it will change to a less than, and this will be a minus 3. And then this will cancel out, and this will just be x plus 2 is less than minus 3. All right, that was a little tricky, and you have to be extremely cautious of this problem when dealing with negatives out in front. So now we're going to we can add or subtract across this without changing this. So we're going to subtract 2 from both sides. So now we have x is less than minus 5. All right. So our other answer was x was greater than 1 from the previous section or previous part of our ELM prep. So we have 2 possible answers here. So let's look at this. The absolute of x plus 2 is greater than 3. Let's put this on a number line. Well, we said that one of our answers was x greater than 1. Well, this other answer implies that it is less than minus 5. So out here at minus 5, it's going to be less than that. So we're talking about our answers being down here that are more negative or less than 5. So what we ended up with, because of this greater than symbol, we ended up with a split in our answers. Some of our answers are down here, some of our x's are down there, and some of our x's are up here. So they might ask you, what is the domain of this? And I'd be from minus infinity up to, but not including negative 5 because I don't have an equal to here. If that were an equal, I would include it. Up to minus 5. And then we have a skip from 5 to 1. And we say, or the answer could be from anything above 1, not including 1, up to positive infinity. The parentheses here means not including. If I had an equal sign here, that would change this to a bracket. It wouldn't change the area where my x's lie. It would just change the symbol here to a bracket. It would then be this kind of situation. But if I do not have the equal, then I put a parenthesis here to indicate that it does not include that value. Does not include that value. So I would then make both of these parentheses. We never include infinity. We can't reach infinity, so we're always putting a parenthesis with infinity. So the domain of this, the possible answers lie between this region and or this region. So we use this symbol here, which means or. It could be here, or it could be up here. Here or here. All right. So those are absolutes dealing with inequalities. All right. So the other thing we want to talk about here is the inequality symbol. Well, if I say x equals 5, that's it. This side is the same as this side. Well, that's pretty straightforward. You probably don't have a problem with that. But if I say x is greater than 5, you say, oh, okay, it's it's greater than 5. Okay, so 6 or 7 or 8 on up. But what about x equal to 5.1? Well, that's greater than 5, so it's still true. 5.001, that's still a little more than 5, so it's still true. So then we begin to say, well, what is the region defined by this statement? So here's 0 and here's 5, and we say it's all values greater than 5 up to and including, or up to whatever infinity is. So the answer to the x here is a whole region of values. Unlike x equals 5, there's only one value here. Whereas an inequality sign gives us a whole group of values that would be true for this situation. X could be 6, and that would make it true. If x equals 4, then it's not greater than 5, and so it's a false statement. So anything down below 5, 5 included, if I said it was 5, 5 is not greater than 5, it's equal to 5. So this would be a false statement. I could not include 5. It has to be something greater than 5. All right. So the inequality symbol can be a little tricky. Okay. So looking at this. This says x is greater than 3 or equal to 3. So in this case, we could have x be equal to 3, and it would be a true statement because we're saying it's greater than or equal to. So it could include 3 and any value above. So we'll use this bracket symbol to show that it includes 3, and I might write it in interval notation. I might say bracket 3 up to infinity. We do not include infinity because we can't find it. So this would be my statement of value or truth table for that statement. Or often we'll call this the domain of x in terms of that statement. All right, so what if we say, what if I have a problem here and I tell you that that x lies between these two values. My x lies between these two values. Well, I didn't say it equaled that value, so it goes up to but not including that, and up to but not including that. So then I say, well, x is between 5 and minus 3. Well, if x is up in this region, it's greater than that, so it's greater than that value, but it's less than that value. Now, notice that these go in the same direction. The arrows point in the same direction. So x lies between these values. It is greater than this value or above this, but below this. I might say that x, nice, I'm running out of ink on that one. I might say that x is neither less than minus 3 nor greater than 5. This neither nor business, don't let it mess with you. This just means not. X is not less than minus 3. It's not less than minus 3. It's not greater than 5. So it's below this and above this. And so then I have my region. So don't let the x neither less than this nor greater than this. Don't let the neither nor throw you. They're both interpreted as not less than this. So if it's not less than it, everything below is out. Nor greater than, it's not greater than 5, so everything above is out. So the only thing included is the values between those. All right, once again, we're running up on the clock. So we talked a little bit about the absolute value of x and a little bit of discussion on it being an inequality value. We talked a little bit about the idea of values in between, and the inequality symbol less than or equal to, greater than or equal to, less than something or greater than something. We'll talk a little more about this as it comes up. Thank you for listening. Hope that was helpful, and we will see you again. Have a good day.